I'm going to explain to you line by line the Hello World program for x86 machines running Linux. On the left here is the actual assembly program. On the right we have the same program written in modern C, omitting the standard input-output library because it's not necessary for this explanation. So the assembly program begins with this line up here, section.txt, and what this is saying is that this section here is the actual code. This will be run on the CPU. Just below it says global_start. All this is doing is telling the assembler to put this function _start in the resulting object file. This allows for that specific function to be used by other files if needed. Here it's just to make it visible, the equivalent of the main function in C being the one that is ran in the hello world. Now for the actual function, _start is the assembly equivalent of main, which we see in the C hello world. This is where we get to the real code, the CPU instructions. We're going to do a little back and forth between this and what's in the .data section down here, so I'll explain this first. The .data section just contains what is used in the code that isn't actually code. You can see here that we're defining the constant MSG, which is short for message, as hello world. The dB in this context just means that we're actually assigning the address of this text to the constant called message. This makes calculating the length of the text a lot easier, which we can see just below it. Here we're just assigning the length of the message to a constant called len, short for length. We calculate it by taking the current address of the program and minusing the address of the message from it. This gets you the length of the message. If you're unfamiliar with the concept of addresses, all they are is just where something is located in your computer's memory. It's basically the equivalent of measuring the distance from you to your neighbour's house by taking your exact coordinates and minusing your neighbour's exact coordinates from that. Now, I've explained that, we can get back to the start function. You'd think it would begin at the first line, and you'd actually be wrong. It starts down here, where it says MOV, short for move, EAX, 4. You may have noticed that these seemingly random letters are actually all related, because you can see here it says EAX, EBX, ECX, EDX. It's in a reverse order. These are, they're all related. What this line here, the EAX line does is tell the computer what function you're wanting to use. We are telling the computer to use function number 4, which is called write. This function is used for output, i.e. writing something. Now, above that is the first argument of the function, EBX. This first argument is used to tell the output type 1, which is called standard output, because we just want a plain standard text output to the terminal, so we just want to select standard output, which is 1. Now our second argument is ECX right here, and all this is asking for is the address of what we're wanting to write. It needs to know the address in order to know when to start writing. Luckily for us, we calculate the address of the message already down in the .data section here. As you can see, it's the message line. We called it MSG. So we say that our argument is MSG. Now for our third and final argument, we need to tell the function how long our message is. This is so it knows when to stop writing and to continue with the rest of the program. So you can visualize it as a whole bunch of memory here, and then our text there and a whole bunch of memory there. So our message is located in here. Just write hello in there for now. MSG tells us basically where the start of this is, and len tells us practically when to stop. So the computer counts using len. So it starts here and it counts 1, 2, 3, 4, 5, which is what len is going to be, or at least in this example. So when the computer has reached length from counting, it stops output and it continues with the rest of the program. And that is pretty much the function. This is the full function call. We can abstract it by visualizing it like a regular function in a simpler programming language. So it's a function called write. First argument is 1. Second argument is our message. Third argument is the length. Now you see how almost simple that is when you take everything from here and just visualize it as something a bit simpler. You might have noticed that below all this there's this strange little line here, int 0x80. And all this is it's called a system call. And what that does is it tells your computer that we've written a function above this and we want it to be ran. And we're telling the computer, run this please. And that's all it does, because we specified what type of system call we use, the function, and we wanted to use write, which is 4. And we're telling the computer, do this and use these arguments. And that's pretty much it. This is near enough the equivalent of the printf in C. And you can see exactly C. You can see exactly where everything goes into it, or sort of. See our message is there. It more or less gets abstracted into printf quite a lot, but you see where I'm coming from. Now you see below this that we have a different function here. You know that this is a function now because we've established it here and it has a little syscall down there. It's pretty similar, right? It's just another syscall. And we know now that we read it backwards from bottom to top. The EAX line is saying that we're using function number 1. That's what EAX always means. We're asking for a specific system call / function. 1 is the exit function, at least in Linux. This exits the program and returns the user to whatever they were doing before they ran it. The EBX line, our first argument of the function, is 0. All that 0 means is that the program has ran successfully and is going to exit successfully. So we give it an exit code of 0. And you can see here that it's almost identical to return 0, except without words, obviously. EAX would be the return and the EBX would be the first argument, which is 0. It's easy, right? And obviously we tell the computer to call that. And that's pretty much it. That's the full program done. You would then use something called an assembler to turn this code into the 1s and 0s that the computer understands, which is a process I can explain another time. Using an assembler like NASM, you get an executable file, which I'm sure you've used before. It's the 1s and 0s that your computer can run. If you run that executable, it just prints hello world to the screen. Simple.